Welcome to this 50,000-foot overview of configuration management. In this video, I'll tell you why you would want to perform configuration management. I will use the shorthand CM to avoid saying configuration management so many times. Then I'll go into the definition, history, and elements of CM. Next, I'll give you 10 ideas for improving the state of configuration management at your company. Finally, I'll give you 3 resources for learning more about CM. Why would you want to practice CM? First, it helps ensure that your products meet the requirements you define for them and that you are following your specified processes for engineering, manufacturing, purchasing, and production. Next, a known configuration empowers you to make the same product repeatedly with quality. Third, every variance, waiver, deviation, or discrepancy slows you down. Every time your product doesn't meet requirements results in an intervention. Those intervention resources and corrective actions result in waste and lost money. CM improves the bottom line, reduces time to market, and increases profitability. Here is a definition of CM from the CMII standard. I'm not going to read it to you. You can pause the video if you want to. I've highlighted several important words. CM is about your products, facilities, and processes. Specifically, it pertains to the requirements, changes, and results of your products, facilities, and processes. CM got its start in the military-industrial complex during the Cold War. A lot of new weapon systems were being developed, and the Department of Defense needed a way to manage it all. Various standards were developed. The current one is Mill Handbook 61B, released in 2020. A civilian version of CM followed soon after the military one. That one expanded to CMII to reflect that it encompasses and integrates both configuration management and change management. The current iteration is known simply as CM2. A standard for CM was developed by the Electronics Industry Alliance. That is known as SAE EIA 649, and the current version is C. CM comprises a number of fields. Let's talk about them. Requirements are the foundation of CM. For that reason, CM has a lot of overlap and interaction with systems engineering. One of the biggest mistakes I've seen with CM is that organizations don't want to commit to requirements and requirements decomposition so that they don't have to hold themselves accountable. Whatever we build, that's what our product does. If your organization doesn't manage changes well, please look at the closed-loop CM2 change management process, including enterprise change requests, enterprise change assessments, enterprise change notices, and application orders. Before anything gets manufactured, procured, or assembled, it should be released by engineering. Organizations generate a lot of records like testing, purchasing, production, and sales. You need to store and manage those records just like you need to store and manage the documents created throughout the enterprise. Your engineering definition compromises mechanical CAD, electrical CAD, software, firmware, and more. You need to manage that data, including vaulting, access control, releasing, revising, and visualization services. Your engineering definition includes bills of material. Most organizations manage at least an engineering BOM and a manufacturing BOM, although you may also have purchase BOMs for how you procure stuff and finance BOMs, which reflect the total cost of a product, including labor. Last but not least, you will have items under configuration control, including data, documents, and, importantly, physical objects like your products. Speaking of which, there are a variety of configurations that you want to manage. First, there are the actual products that come off your assembly lines, especially if they are serialized or require maintenance. You may hear those referred to as the physical twin. The digital twin is the electronic representation of a physical object. The as-defined configuration comes out of engineering. It can be represented by the engineering bill of materials, CAD models, and software. The as-manufactured configuration is what's actually produced. This can be defined by the manufacturing BOM, work traveler, and the bane of CM, variances. Those are deviations and waivers which explain how the delivered product differs from the approved engineering definition. After the product is delivered, you have the as-maintained configuration, represented by the item master record in your enterprise resource planning or ERP system, and the service BOM. Another term you will hear is digital thread, which represents the digital twin over time. The idea is that you can pull on the digital thread to know the exact configuration of your product now or at any time in the past. Finally, in the definition for CM, I talked about how it's used to organize not just products and processes, but also facilities. You should have a known configuration of your factories, and a relatively recent concept is having an electronic version of them, the digital factory. If you want to get started with or improve your product development organization's CM, here are 10 ideas. Here are 3 resources to learn more. For more information, visit www.mcaeconsulting.com. Thank you very much.